Good afternoon, Miss Vides.
Good afternoon. How's it going?
I have a question. Good. I did the Halloween bonus today
Yes.
with some people, persons, and it's everything went well, but
Okay.
I need to ask you a question because that bonus only had one attempt, and I did it
Uh-huh.
before,
Right. I know. I saw
not
that.
doing not
It's
doing the
okay.
right thing.
Whoever your
But
group is, you can post,
uh-huh.
they can post it and then I'll see yours too. So it's okay.
Okay.
And
Uh,
make sure that
I could
everybody
attach it.
is on there.
Okay, I could attach it. Like like a message or something.
Sure. That works too.
Okay. Okay. Thank you.
Sure. No problem. So did you have fun doing it?
Yeah, actually seeing it like reverse back to its original color. That
Uh-huh.
was cool.
Yeah. See, that was the idea behind it, that you did something for points, but also had fun. Because that's what, and I see everybody that's here right now, except for Kia and me, I think, did the experiment so far. Well, I
Hey,
don't
I'm
know.
here.
I know, I'm just
Kia's
saying,
here.
did you do the experiment
Oh,
too with Jean-Marie?
yes, ma'am. I did it with their group. Yes, ma'am.
Okay, I'm just checking. So, because I
Okay, I
don't
thought you
know
said I
yet.
wasn't here.
No,
Okay.
no, that's not what I was saying. I said it. Everybody that was that I'm seeing that's here has done the experiment, except for maybe me, Evan. Did
Oh,
you
you
do
said
it,
Mia.
ma'am?
No.
No? Okay. Just checking. Like I said, it was just a curiosity question. All right. So today we are finishing up. Isn't that amazing? We are looking at
You
acid.
said today's the last day?
Uh-huh. Basically, well, the last day of class.
Oh, loser.
We are going to review from now on, right? Okay. 1, 2, 3, 4, 5. So far, 5. Yep, that's what I got. Okay. Yep. So let's just get on started because acids and bases can be a little bit interesting, to put it lightly. Okay, so we are going to go all the way down to the acids and bases. Right here. Okay, acids and bases introduction. All right, so acids and bases are differentiated mainly by their pH, but not only by their pH. There's actually several definitions, quote unquote, for acids and bases, and we're going to look at all of them. All right, I am not sure if this is the right PowerPoint, so let me check first and see if this is it. If not, it's the other one. So I always give you more than one just in case you want to look at something else. And don't look at those pages. Those pages were for an old textbook when I did this PowerPoint, been a while. So, okay. Yeah, this is just telling you how to name it. This is just a naming. And we've already done that. So no, this is not the right one. But this is just in case you want to review it. It's right here. All right, so let me go back and get this one off of here because it's not the right one. All right, let me see. Okay, go back out of here and go to the other one. So it is the student. I thought so. I wasn't sure, so I just checked the first one that came up, but it is this one. It is definitely the one that says student acids. Not that one. The student acids and bases, this one. This is the one we're going to look at. Okay. All right. So, like I was saying, acids and bases are mainly distinguished by their pH. But pH means potential of hydrogen ions. So, what does that mean? That means they contain hydrogen ions, but not all acids do that. Mostly, yes, but not all. So there's a little questionable thing here. So this is what I wanted to go over, is the different definitions of acid and bases. Yeah, it's okay. All right. So all of these things right here that you're looking at, that's everything in this world pretty much can be classified as an acid or a base. All of these right here. I mean, even a tomato, I know, meat, fish, yes, everything. All right, so acids and bases are characterized because they are tart when you eat them. So you can imagine lemons, oranges, grapefruits, and vitamin C. Yeah, vitamin C is actually an acid. Those of you who did the experiment with the fruit fresh, and you heard the actual name of it, might remember it. Do you? No? Just wondering. It's ascorbic acid. That's what a vitamin C is. So it is an acid. And yes, it is kind of sour, isn't it? All right. And when ants bite you, they actually are injecting you with a little bit of formic acid, which is the simplest organic acid there is. I'm hearing my phone, but I don't find it all day long. Okay, anyway, so here we go. So all of these things are interesting. Now, and like I said, there are some that are acids and they don't look like acids because, you know, they don't necessarily have the hydrogen, but that's okay. There are different definitions that catch them all. So aspirin, for example, is a weak acid, and it's what is known as a carboxylic acid. Those of you who are familiar with some organic nomenclature would know that this is carboxylic acid because this is the carboxyl group. And an amino acid has both. Interesting enough, amino is the basic side, and acid obviously is the carboxylic end. So you have the amine group and you have the carboxyl group. And so you've got an amino acid is both acid and base. And that's for you in biology. So you remember this stuff, probably, right? All right, let's keep going. And glycine happens to be the simplest amino acid too. All right, coffee. You drink coffee and it's acidic, but you know what? It's not. It's a base. I know, right? And you know it's a base because of all the nitrogen that it's got, in addition to other reasons, but the nitrogens make it pretty much a base. And these little guys right here use it, concentrated sulfuric acid, as their defense so that other things leave them alone in the ocean. They just secrete it, push it out, and the fish or whatever trying to eat it have to step away because it stings. All right, so here's the differences between them. So acids have a sour taste. Vinegar is actually a solution of acetic acid, which is an acid. And as you know, citrus fruits contain acid, and all of these have a sour taste. They react with certain metals to produce hydrogen gas. That's very important. They react with carbonates and bicarbonates to produce carbon dioxide. Bases, on the other hand, have a bitter taste. They feel slippery. Have you ever had like a bar of soap and accidentally your nails caught a little bit of it and you put it in your mouth and it was like, that's so bitter, right? I know I've done it before and it's really nasty. Yeah, it's very bitter. And that's what a base, but don't be tasting everything, okay? I'm just telling you that this is one of the reasons I know for a fact is because I actually tasted it, not wanting to. All right, so here are the actual properties, chemical properties of acids. They will produce hydrogens as, this is known as the hydronium ion in water. They will taste sour, they will corrode metals. That is a physical first, the taste, and the corrosion is a chemical. They are electrolytes, that means they are charged, right? They react with bases to form a salt and water. And there's the key when you are trying to figure out if you have a acid or a base, you're going to do a pH. And there it is, pH less than 7. And it will turn blue litmus paper to red. So blue to red, remember that, blue to red is acid. All right. To name them, just to remember, you have binary acids and you have ternary acids. Binary are just 2 elements, one of them being hydrogen, and ternary are 3 elements, one of them also being hydrogen. And there's a little difference between them because you got to use the hydro prefix in the binary, and then the rest is ic acid, which is the same. But ternary, you still use the word acid, but the stem of whatever it is, let's say it's sulfate, so it's sulfuric acid, and sulfite would be sulfurous acid. So remember that whenever you're looking at acids, you have this also this nomenclature flow chart, but we've already covered this. That's just a quick remembering. All right, in order for a binary acid to be named as the acid, it has to be in its aqueous form, hence the word AQ, the little label right here, AQ. Well, hold on, I'm pointing and I know you can't see that. I keep forgetting. I have to use the spotlight. Okay, right here, the AQ on there. The other ones don't need it, okay? So since it is a binary, we would use the word hydro first, then the stem for the bromine, so brom, and then ic, and there it is, hydrobromic acid, okay? This one, since it is carbonate that is bonded to the hydrogen, we would use carbon, change the A to ic, and it's carbonic acid. And then the last one over here is H2SO3, which is sulfite. So sulfite is sulfurous acid. You see? And that is what we know. All right. So just like I said, just to remember, what on earth is it doing? Oh, okay. So here, name them quickly. Anybody? And put them in the chat. Nope. Nope. No takers.
What you said? I'm sorry, I went in and
I
out.
just say name. You can see my PowerPoint, right? Because it looks like I'm sharing.
Yeah.
Okay. So just name these. Name them. What are their names based on what we just did? We just practiced. So this is binary. Therefore, you would use the prefix, right? So you would have hydro, right? And then the next part is iodine, so or iodine. So you take the iode and then put ic at the ending, acid.
Is the first one hydro acid, hydrochloric acid?
Hydroiodic.
Hydroiodic acid.
Yes. The next one, being a binary again, would be what?
Hydrochlorine acid.
Chloric. Remember, it always ends in
Chloric.
yes.
Hydrochloric.
All right. The next one, depending on whether you have an ite or an ate, right? You will name it as ic or ous. So in this case, this is the SO3, which is a sulfite. Therefore, this would be sulfurous acid. What about the next one?
Surf. Is that one? Nitric acid.
Nitric. Very good. Yes, ma'am. And the last one is a little interesting because you got to know what IO4 is first. And do you know what IO4 is?
Hydrogen, oxygen, and
No, just IO4, not the
Oh,
hydrogen. That makes the acid, but IO4, just the IO4 negative is what it would be. It is a polyatomic ion, but what is its name?
polyiodic acid.
Periodic acid. Yes. Almost looks like periodic, but it's not, it's periodic. All right, so bases, again, produce hydroxide ion, in water. They taste bitter, chalky. They are also electrolytes because they produce ions. They feel soapy, slippery, react with acids to form salt and water, just like acids and bases always react, right? So same thing. pH is greater than 7. This is backwards. And it turns red paper to blue. So basic blue, it becomes from red. All right, so here are some names and what you know them as. Lye, you've heard of lye. You know that you use liquid soap all the time, so you're actually using potassium hydroxide. If you have used any plastics, chances are you had some barium hydroxide in there. And if you've ever had the milk of magnesia, or otherwise known as mom, over your tummy when it was hurting, then you had magnesium hydroxide. And if you have ever had a Maalox tablet, then you had, or a Maalox liquid, you had aluminum hydroxide. These are bases. And yes, because they're bases, they react with acids and they neutralize them. And they produce, and this is why they're also antacids. All right, so here's the definitions. You want to write these down because they will be in your test. So definition number 1. This is an Arrhenius acid, or Arrhenius. It's the traditional method, so acids will produce hydrogen ions or hydronium ions in water. Bases will produce hydroxide ions. See, the problem is some of these do not have hydroxide ions, so that's why they had to come up with another way of naming them. So this is just a hydrogen and hydroxide difference, which is what we know already. So right here, an Arrhenius acid reacting with water, see how it dissociates the H and the Cl, will bond to the hydrogen and the chlorine will be by itself. So the hydrogen will bond to the water, produce hydronium ion, and be by itself. And there you go. The same with the base is the opposite. The hydroxide, the water will actually give up, I guess you could say, a hydrogen ion, and it will produce ammonium and an ammonium ion and hydroxide ion. And there's your hydroxide production. So that's the Arrhenius acid and base. All right, so now we have definition number 2. Now we're saying that acids are a proton donor. And if you remember, hydrogen is the only element that has no neutrons. So when hydrogen is a plus, all it is a proton. So that's basically like what you're saying. It donates hydrogen, right? And bases accept hydrogens. So look back here. Hydrogen was donated. Hydrogen was accepted. You see that? So there you go. Same thing. This is the acid. This is the base. Oh, sorry. Here I go again, pointing without the pointer. Okay, so let me move this back over here. Okay, there we go. So like I said, this is the acid because it's the one that gave up its hydrogen because it became just a chloride ion. And this one's the base because it accepted, you see that, a hydrogen. So the definition kind of match hydroxide and, you know, the hydrogen and the hydroxide thing. Not always, but they do match. All right, so let's keep going. And water, by the way, can act as both an acid and a base. And here it's acting as an acid on the bottom, and here is acting as a base. And we'll see that in a minute also. All right, so let's keep going with the definitions. There are 3 types of definitions. So here's a Bronsted-Lowry acid definition. Look at ammonium being formed. Where did that hydrogen come from? The water, right? So the water gave up its hydrogen, therefore it donated it. It's an acid. The ammonia accepted it and became ammonium ion. And so ammonia is the base. Now, when you have a Bronsted-Lowry acid and base, there's also what is known as a conjugate acid and a conjugate base. And you notice that they're different colors, so they go with each other. The conjugate base and the conjugate acid. Okay, the conjugate base goes with the acid because it came from it. So, oops, let me see. Go back. Sorry, I meant to put a line right here. This, right? Okay, so this right here was given up and it formed this. So these two are its own, what is known as a conjugate acid base pair. See that? And this one accepted it right here. Well, actually here, because there's nothing there, and accepted it and became that. Oh, let's do it from the bottom. And it became that right there. So that right there is its conjugate acid base pair right there. See? So that's what you have to know in order to do certain calculations with acids and bases. So we are going to now continue. But remember, acid and base conjugate pairs. Okay, so we are looking at next. All right, so all right, and that's just the same Bronsted-Lowry. All right, so there they are, conjugate acid and bases. These are not your everyday ones. This is actually carbonic acid. Have you ever had soda? Of course you have. I know that answer. Everybody has. Okay, so you know that there's carbonic acid in it. Well, this is one of the states of decomposition of carbonic acid, which is really H2CO3. And the ion this is the second decomposition of carbonic acid, because there's several, you pull one at a time, not both at the same time. So the first would have been H2CO3 plus water equals HCO3 plus OH, basically, or something like that. In this case, this is the second one. It already has one pulled off of it. So this is the hydrogen carbonate ion, which is now reacting with water, right? So what is it going to produce? Well, since it is the acid, it's going to donate this particular hydrogen, right? It's going to go away, and look, there it is. It's gone. You see that? And water is going to accept it, and there it is. See? Oops, sorry. There it is right there. Accepted. Okay. So that's why they are conjugate acid base pairs, because this one formed that, and this one formed that. You see? All right, it's clear. Yeah. Now let's go to another. Now, okay. Let's see if you can do this one. Label the acid base, conjugate acid, and conjugate base in each of these reactions. And I know it says honors only. This was when I used to teach AP Chem, so it's all right. It works with you guys too, because you're in college. So this is AP Chem. All right, so who's losing? Can you see? Just tell me. Who is losing a hydrogen?
You said who's losing a hydrogen?
Hydrogen. A hydrogen. Yes, ma'am. Who is losing a hydrogen out of these guys?
The first one, C,
The first
hydrogen
one.
chloride.
That's right. So by definition, if you lose a proton, which is a hydrogen, you are the acid, right?
Yes.
Okay, so we're going to put a little text box under here, and we're going to put acid underneath. All right. Now, who is gaining the hydrogen?
The HOH.
Right. So
To
if
make
it's
H2O.
gaining a hydrogen, it's gaining a proton, right? So this is the base. You see that? Now, what is its pair? What is the first acid? What is its conjugate base? Which one of these?
You said what again?
Which of the ones, the products, right? Because of the ones on the right, is the conjugate base of the acid?
The hydrogen base.
The conjugate base. So conjugate base. Which one is it?
The hydrogen base is Cl negative.
Cl negative. That is correct. And which one's the conjugate acid?
It's H2O.
That's correct. See? So you can actually definitely, identify them based on where you just got to follow what? The hydrogens, right?
Mm-hmm.
And see where it came from, where it landed, and that kind of thing, and you can identify them. Okay, so I'm gonna let you do these next ones. You tell me what water is in this case.
So the one that's losing the H will be the H2SO4.
Correct. And that would be the what?
That would be the conjuring base.
No, not yet.
Oh.
Not yet.
That would be the then that would be the
yet.
that would be the acid.
Correct. And then that makes water, obviously by default, right? The base. Yeah. Mm-hmm. Okay. So which one of these is the conjugate acid and which one's the conjugate base?
The conjugate base will be conjugate base is the HSO4.
Okay. And then
the conjugate acid is H3O.
Very good. See? Not so hard, right?
I'm just
no, you did good. Don't even try to put yourself down on that one. You did good.
Okay.
You understood it. You couldn't have said this. It doesn't just happen by, pure chance. No, you identified them all correctly. So no, you know what you're doing. You understood it. Believe me. You did.
To a certain extent, I mean, it's kind of simple. I mean, if it's basically if it's a base, then it's gonna end up being the conjugate acid. If it's an acid, it's gonna be the
Right.
conjugate base.
So the key to this particular thing is to identify the acid and base correctly, right?
Mm-hmm.
Very good. All right, excellent. All right, let's keep going. All right, now here's another definition, and you're just going like, there, how many definitions are there? 3. There's only 3. All right, this is the last definition, and this is called the Lewis acid and base definitions. Because not everybody has, and this is the one that's going to be very important for you when you take organic chemistry. Very important. Because in organic chemistry, what you do is you follow the movement of electrons, and that's what this is doing. So, definition for Lewis acid is a substance that accepts an electron pair, not donates. You notice so far it's been donation, donation, donation. No, this time it's accepting it. Okay? And the base, obviously, is the one that gives it up or donates it. Okay, so you got those two. Now, this is why it is important to know Lewis structures, because you have to know who's giving up what. If you don't have a lone pair, you can't give it, can you? So, since it is accepting a lone pair,
Mm-hmm.
then this is the acid, very obviously. And then this one's donating. And I'm saying this one and this one. I'm sorry, this one right here, right? And this one is donating it, and it becomes the base. And this is known as the adduct. Yeah, that's known as the adduct. We'll talk about it later. But so that's a very good example of a Lewis acid base. You notice you didn't really need 2 products, you just needed 1. Because all we're looking at is the electron pair. Where is it going? Okay.
Okay.
All right, look at these. All right, so this is an acid, obviously, because it has no lone pairs. It joins the Lewis base, and it becomes the adduct. And then this one is the acid again. It joins the Lewis base, which is the one that's donating, and it becomes the adduct. So the formation of ammonium ion is also a good example. All right. And in biology, it's very important. Why? Do you know what this is?
No.
You don't know what a heme group is?
No, ma'am, I do not know what that is.
Okay. It is. This is your blood. Okay. And every single red blood cell has heme groups.
Mm-hmm.
Heme groups contain iron in the middle. That's why when you're anemic, they say you're low in iron. That means because you have lower count of red blood cells. All right. So they are the ones that carry around oxygen to your cells. Okay. And this is why carbon monoxide kills you. You can see why, right? Because it takes the place of the oxygen and you suffocate because no oxygen gets to your tissues or anywhere in your body because the CO has bonded to that heme group that normally carries the oxygen around. And that's why CO is known as the silent killer, carbon monoxide. It'll kill you.
So that's how you kill people?
Mm-hmm. That's when, yeah, that's why some people, I don't know if you've ever seen movies and stuff where people close their car and they put a pipe into their car and that's how they commit suicide.
No, never heard of that.
Okay, well, that's one way. And the reason they do that, it's because carbon dioxide is heavier. Yeah, heavier than oxygen. So as it's filling up, it's pushing the oxygen away from you. And then all you can breathe is CO2.
So basically, you're suffocating yourself.
Exactly. Just like you're doing here, except here you're suffocating at the cellular level. Yeah, I know. It sounds horrible. But so that you know, the Fe ion, right, which is the iron that's in the middle, doesn't have any lone pairs. Therefore, it is a Lewis acid. And the oxygen acts as a Lewis base because it's donating. See, pretty cool, huh? Nice to know how breathing happens. This is all it is. This is respiration right here. All right, here's the pH scale. So this is a way on how we express the strength of acids and bases. So this is one of the main reasons why your calculator needs to have a logarithm function. Because if you don't, then you can't do this part of our class. And next time, in the next class, Chem 2, we continue with this. So yeah, we need that log. All right, so pH of common substances. Look here, you have from 0 to 14. That's a general pH scale. 7 is neutral. Look where blood is. Just a little bit on the basic side. You see that? Because it's past the 7, so it's higher than 7. 7 right here, let's just say right here, and just try to make a straight line there, as straight as I can get, is where it is the neutral. This is neutrality right there. Okay. This way, it's acid. And let me do it in blue, so that way we go with the colors. And this way is base. You see? So all of these, remember all of our characteristics of acids and bases. They're sour, vinegar sour. Soda's kind of sour, but it also has carbonic acid in it. That's why the carbon, the carbonation. So there you go. And oranges are kind of sour. They have citric acid in them. Blood, on the other hand, I've never, well, I mean, you've tasted it if you've ever busted your lip or something. So it kind of has like a metallic taste. And that is the iron in it, by the way. So right here, this is where blood is. And there's ammonia. Ammonia is, remember, it was a very big base. Well, when you clean your oven, you're using easy off. Look how much more basic that is. And yes, both acids and bases corrode. They both will make holes in laundry. They will both do everything, because when one reacts with the other, one acts as an acid, one acts as a base. So it doesn't matter which one. You're going to end up with the same problem. Okay, so let's keep going. And let's go here. Okay, so in order to figure out the pH, you have to do this, which is your pH is equal to the negative log of the concentration of hydrogen ions. And in hydrogen, what it means by concentration, it's a molar thing. So it's moles per liter, okay? So when you're given the concentration, they usually just give it to you. They either give you the pH or the concentration, and you have to convert one to the other. All right, so normally, if it's just pH 10, it's easy, right? Because the concentration is going to be 1 times 10 to the negative 10. Very easy. So it's just a pH 10. But if the pH is weird like this one, it is not going to be 1 times 10 to the negative 5. But it's close. You see how it's closer to negative 5? And this one right here, since this concentration is so low, the concentration of hydrogen ions right here is low. This is a base. See, right here, this is a base because it's higher than pH 7. Remember, we said that. And now this bottom one is a 4.74. So this is an acid because this concentration is much higher. Okay, that one's low, this one's high. In comparison, of course. And the pH being below 7 indicates an acid. All right, so let's do some calculations. You got to take out your calculator. I know, right? And see about these. Okay, so how would you do these? All right, so you've got a pH that you want. So that means you want a number and they've given you a concentration. So we just saw how they did that. Where is my calculator? Oh, let me go get it. I think I left it in my bag. I got it. All right, so how are we going to do this? All right, based on what we know, we can go back and look. See, to get the pH, right, we're going to take the negative log of whatever the concentration is. Okay, so we need to say, if you have the type of calculator that I recommended, you're going to do negative with the little negative that is got the parentheses on it, negative, and then hit the key that says log, which is right under the second key. And then you're going to put 0.15 plus that parentheses and hit equal. And the answer to this one is 0.8230908. So pH is 0.3. That's very strong, right? And the next one, okay, now the same thing. We don't have pH, we need pH. So we're going to do the same thing with that one. We're going to say negative log of 3 second EE negative 7.
I don't think my calculator does the negative log.
Okay, and this one's going to be, see, that's why you need that one, because you can't do this work without it.
I have the one that you recommended, but
oh, it has it. It has it. It has it. Okay, so you have the TI 30X2S.
TI 30X. Oh, I got the TI 30XA.
Okay, that might be, but it should have a negative log. Let me see it. Can you put it on your screen?
Let me share my screen. Give me 1 second.
No problem. I just want to
Can I see? How can y'all see me on here?
Well, I will escape from here, so that's why I'm asking you to put it up with plenty of time so I can see you. I'm going to stop my share so I can make you bigger. There we go. Now I got you.
You can see me. Oh, goddamn. Okay.
I can see you. You look
Sorry, I look hot mess.
No, you look cute. You look cute. All right, so put it closer than that so I can really see it. There we go. All right. Let me see. Make it bigger. Oh, I cannot make it too big. All right. I do see it. It is there. Hold on. How do I make this bigger? Control plus, maybe? Nope, that ain't working. It is not letting me. What if I just want you on the picture here? How do I do that? I'm looking. Hold on. Don't give up on me yet.
I'm not. I'm trying to turn the camera because I don't try to see my
I'm trying to figure out how to make you
I
bigger.
don't try to see my floor either.
That's the one thing. Maybe if I say put only the people with pictures on, might do it.
Oh, get off.
Nope, that's not working. Oh man. I am not seeing you. How do I do this? Stop video. Pin. There we go. I'm going to pin you. There we go. Now I can see it. All right. Yeah. See? Okay. So yours is to the, okay. So I'm looking at the calculator. It's to the right of the second key. Yeah. It's where it says no, not LN, log, L-O-G. See it? Okay. So hit the key that is down there.
It's down here?
Yeah, clear it, but put the negative first. Put in down here, this negative, not minus, but the negative key part. Yeah, that one. Now hit log.
Does it say error?
Didn't do that. Okay, don't do negative log then, just do log. Oh, maybe yours is backwards where it needs the number first. Okay, try that first. Try your number first. It was 3 times 10 to the negative 7. So put 3.00. Second EE.
Huh?
So your green key, second first, EE next. Then put negative on the bottom. Oh man, why is it doing that?
Point
It should do it. 3.00.
second E.
Second EE,
error.
negative 7. It shouldn't do that.
I do.
Yours is totally different from mine. 3 second EE.
Second.
You got the EE thing. And then
EE right here, right?
EE there. But did you hit the second?
Yes, I did.
You sure?
Yes, I did. 3.00 second.
EE negative 7. Oh, that's crazy. Man, mine.
Maybe do I need to put it all in together first?
Maybe so. Try doing it the other way. Try put negative 7 first and then do second EE. I don't think that'll work, but
negative 7 first and then second EE.
EE. See if that'll work. Nope. See, it's not doing it. That is weird. You should have gotten the 30X2S.
I thought that's what I got. That's what I got from Walmart.
Yeah, it is sort of the same, not quite, but it is needing that extra. I don't know. You might have to check it out and see how that works. But okay, so let's continue to do the PowerPoint here and finish that part. All right, so we're going to do, and I'm going to tell you the keys that I'm using again. So it was
low.
Yeah, it's negative log and then 0.15 close parentheses equals. And my answer for this one is 0. And I'm just going to write it in, let me see how I'm going to write it. I'm going to annotate it in a text box. That's what it's going to be right here. Okay, I get 0. Oops, that's not 0. 0.8239, and we had 2, so 82. That's the pH, okay? And then for this one, is negative again, so clear everything, negative, and then log, and then put 3.00 second EE negative 7, close the parenthesis, hit equal, and it gives me, and this is 3 sig fig, so 6.52. That's the pH. Oop, that's not a period. That's a comma. All right, there you go. And that's the answers to those. Oops. Well, anyway, those are the answers right there. So if you guys have the type of calculator that I'm telling you how to use, then use this. We'll have to look at yours one day with more calm and see what's going on. Did yours come with a manual?
Not really. The manual is on the It
Yeah,
come with
it's usually inside the case.
yeah, inside calculator, yeah. It's like clear last entry error, clear display.
Okay. Log is on there, so there's got to be a way of doing it. So you just got to look it up.
Second log.
Okay. So now this is the reverse. What if you have a pH already? How do you know what the concentration of hydrogen is, right? So you do the antilog, which is 10 to the x, which is right under, right? If you hit the second key before you hit the log, that's going to give you 10 to the x, okay? So what you're going to have to do is you're going to have to put the 3.12 in negative, so negative 3.12, then second 10 to the x, and then, oh no, hold on, no, mine is different. Second 10 to the x, then negative 3.12, and then close the parentheses and hit equal. And that's going to give me 7.6 times 10 to the fourth, negative fourth. That's exactly what I got. You see that? Or it actually gave it to me in a little bit of a different notation. It gave me this really. But you know how to do this part. 7 parts, 5/8, sorry, 5/8. There. Okay, so that's what it gave me, right? And you know how to do this part. And so it's 7.56, since we can only have 3 sig figs, times 10 to the negative 4. You see that? That's exactly what that is up there. So actually with sig figs, you need that number, that extra number. All right. So to figure those out, you can do it like this. And there's what I love, because after you do a lot of these, you can get a little confused, especially as to which one do I do? Which one do I do? You know, and I do that. So there's something here I call the conversion diamond for these, and it is a great tool. And it is coming up, if I can ever click it off here. There, that one. See how it tells you what to do each time? If you're going from hydrogen ions to log, see it's giving you the next, so you put the negative log to pH, and then from pH to hydrogen is 10 to the negative pH, and so on and so forth. Now, we haven't looked at pOH yet, which is really not a true thing. It is a made up thing, but it's actually calculated from the pH. And it is a pH, has its counter. So if you got a pH of 7, the pOH is also 7. If your pH is 11, your pOH is 3. You see? Okay, so it's the opposite. So basically you're subtracting it from 14. Right, we did those. Did we do those? Yeah, we did those. We did those. Okay. So there's one right there that you can do, and see there's the whole thing, how to do it. Okay, so what is the molarity of hydrogen ions in that solution with a pH of 8.5? So what you would do is you would say antilog, so 10 to the negative 8.5. So second 10 to the negative, and then 8.5, close it, hit equal. And after you do that, this is a big bunch of zeros. So what I do is I hit second science to engineering, change it to science, which is scientific notation, hit equal. And I get 3.1622222 times 10 to the negative 9. See? And there it is, just like I got. All right? So you have to do all of this that way with this calculator, if it's not going to work otherwise. I mean, your calculator works. You just got to figure out how to use it. And I can look it up, I think, and I can give you like an idea if you need me to.
You're very low. I can barely hear you.
You can't hear me?
Barely.
That's interesting. Okay, because most people can hear me. Maybe my microphone is out. No, it's right there. It's looking at me. Okay, I don't know what's going on. That's weird. Okay. So when you're doing water, all right, it contains both. And there's ionization constants and all of this. So we'll finish this Friday, and then next week we'll review. So like I said, hydrogen acids and bases is a little more complicated, and it does require calculator that is scientific.
What time is it?
Now,
It's 3:58 p.m.
can you see my calculator if I bring it up from my computer? Or no? Since I'm sharing, I'm just wondering, can you see that or no? Can you see this? No? So I just moved it to scientific calculator, and this one doesn't have log, so I can't use it. No. Sure doesn't. No can use. Standard scientific. Oh, there we go. Yeah, it does have log. Okay. Can you see it? I'm gonna reshare. Or can you see this? Because there is one in your computer too. If you look it up, you can find it and it's there. See, there's log, and there's the second function. So let's say you were doing 10 to the 8.5, right? So that is 10 to the x. But we didn't do it right because we didn't hit second. Hold on. Okay. So 10 elevated. See, this is different from mine, so I have to figure it out first. But you can do log, invalid input. That's because you have to have your negative part first. Negative. Okay, so if you want to do, like at the beginning, we did 3.5, right? And we did log. Is that what I got? No, I got 8. Oh, I need negative. That's what it was. I didn't do the negative part. Not that negative part. Hold on, clear. This is not working either. Oh, by the way, we're finished. If you guys want to stay for a tutorial on calculators, you can. I'm trying to learn this calculator, hoping that I would help you with the calculations that you need to do later on for logarithm. And can you see this screen or not?
Yes, I can see the screen. It's just you're very low, so it's hard for me to hear you.
Okay, so I stopped sharing, but I'm going to reshare because I want you to see the calculator itself.
I'm connected to my Bluetooth because I can barely hear you.
You can barely hear me, huh? That's weird.
Yep.
That is so weird.
It was just like once you took your screen off and I started talking and stuff. That's whenever, like, once you switched it,
Okay. I'm trying to put my microphone closer to me. Can you hear me better?
yeah.
Hello? No? Should be able to. Interesting. All right, so let me. Okay, so I'm sharing the screen for the calculator here. log. Okay. Problem. See, it says invalid input. Can you hear me okay? Negate log negative 3.5. That's what I want. Negate log 3.5. Nope, it's not doing it. Do I need to hit second maybe? Maybe that's what it is. Second. Maybe so. No, these are the functions for these logarithm y of x. No, we do not want ln. No, we want just log. No, we don't need that. Okay. I don't know. Can you hear me better now, Kia?
Yes, I can.
I
Yes,
put
I
the
can hear you better.
microphone like almost to my face.
Yeah, I can hear you better. I got my headphones in.
Hello?
Can you hear me? Hello?
That's weird. Something is off.
Excuse me, Professor.
That's the
Videos.
problem, is something is off.
Mm-hmm.
Don't know what. I don't know. Oh well. Let's just, let me stop recording